Hello, I'm Mike Augustine, a senior enterprise architect here at HashiCorp. We are excited to be hosting this webinar today titled Badges of Honor Earned While Pursuing the Cloud. A few housekeeping items up front. This webinar will be recorded and shared publicly after the event. And there will be a Q&A time near the end. So please put any questions or comments in the Q&A portal throughout the talk, and then we'll address them then. All right, with me today and the main focus of this webinar are a collection of extremely experienced cloud professionals from ECS Tech. Now, ECS is one of those companies that is doing it right. They use all the cool tools, but do the practices and transformation needed to make it function within the organization. I've seen firsthand how they support their teams on the ground and build well-rounded solutions for their customers that grow their customers' organizations, not just their tool stacks. Now, this opportunity is somewhat unique and as such very special to me in that although I am with HashiCorp now, I was previously an architect working with these awesome and smart people. So I am excited to be able to join together again for this information sharing and able to participate from both perspectives. Let me give you a little context of one of the relevant projects that we were involved with together. ECS, of course, has many success stories that will contribute to their perspectives. We had a DevSecOps dream of an opportunity to build a hybrid, multi-tenant, multi-cloud provider, cloud platform from the bottom up. This was for a significant federal agency. We had the flexibility to evaluate and recommend products and tools in an efficient and even low bureaucratic way. And we came to conclusions to use several of the HashiCorp products for a number of reasons, like they just made sense to us as practitioners. And they really appeared to get what we were doing and were a good match with the objectives, particularly pulling off multi-tenancy and self-service. The documentation was clean and seemed complete, but okay, this was a while ago and we later learned it was not always as good as we thought. But now, and with some of my help, HashiCorp has brought this to a much better place and is now in a state of continuous improvement. All right, with that said, let's get going with the program. Today, we invite you to pull up a log or a big rock and join us around the campfire. We are dropping in on some of the brave adventurers that embarked on this journey to the great and mythical cloud. Listen as they regale the tales of those legendary days from the not so distant past. I think Alex the Zombie Slayer is getting ready to speak.
Thanks, Mike. Well, I'm Alex the Zombie Slayer, and without further delay, I'll begin my story of balancing the old with the new. Cloud migrations occur for a reason, don't they? It's true that a migration may be faster than building something new, but runs a particularly frightening risk, sometimes. When you let old applications and old software stacks into your new cloud environment, zombie capabilities may interfere with your new services. Take Console and Bind. Bind has been with us forever. You may have never heard of Bind, but I guarantee it's heard of you, or at least knows where your website is. It's the name service that's always waiting just below the ground to thwart your efforts of modernization. What modernization efforts, you ask? Oh, only important concepts like scaling and containerization. Capabilities make our clouds more adaptable and capable of discovering what is and isn't without static name tables and manual changes. But what if we wake up that zombie? We preach our service discovery mindset to the masses, and an enterprise architect comes and says, what about Bind or Named? I want to continue to use my name service from the days of ARPANET. If we see our name service coming up out of the ground to confound our efforts at implementing the discovery service we need, all is not lost, and we still have some options. We can try to live with the zombie and avoid running into it and having it cause us problems. But creating two separate systems of naming our services and making sure that neither conflicts with the other is pretty effort intensive. We could imprison the zombie, or better yet, the enterprise architect, but not everyone will like that idea. Or we could utilize a tool to chain the old to the new. That's what we chose to do with console-binded DNS mask. Lastly, we could attempt to do away with the zombie entirely. But that's a tall order, considering how long it's lived. In Bind's case, more than 50 years. And how many people have likely tried to kill it already in that time. But if you, brave adventurer and survivor of the domain name apocalypse, wish to learn from our experiences, try chaining Bind to console. You can use DNS mask to forward DNS records to console for discovery and redundancy purposes. This makes dynamic management of your zone files a non-issue and provides light load balancing and service response time checks to your platform as well. To those of you who wish to implement new solutions in place of decades-old capabilities, I advise that it's very much preferable to try and work with your zombie as best you can, instead of trying to kill something that's already been dead. But that's it for my tale. Now I'll hand you off to Chris for his story of a certain drifter.
Thanks, Alex. I'm going to talk about how to see the silver lining in the cloud. My story begins during a dark time in Cyberland. Code was heavy, not easily built or deployed, and bartering was complicated. Tools were in need of modernization. And deep in the dungeons of the Citadel, engineering was being charged on many fronts. Townsfolk begging for new features, competing factions were seizing turf, and the testing fields were lacking adequate resources to provide at scale. Not to mention the shared code base that was being stretched too thin from years at war and had working parts only a few veterans were qualified to maintain. But worst of all, there was a new emperor with interest only on amassing personal wealth to pay himself and his loyalists. He routinely redistricted the guilds, leaving the oldest, most dedicated, and even most patriotic workers outside the walls. But one day, a drifter strode into town. She was a bit of a mercenary, battle-worn from years building client-server and locally hosted systems for the federal hegemony in the East. She wasn't interested in entertaining some outskirt company's difficulties keeping up with the rest of the cyber territories. Every town has problems. Can't fix them all. She just wanted to be left alone, but funds were running low, and she could tell her skills were starting to dull. She would need a worthwhile mission. She scoured the ether, looking for something worthy, but this side of the world was different. There was a lot of action, but it was chaos. You see, many moons ago, guildsmen had migrated to the West in search of silicon, an ingredient heavily sought after in forging their machines. But since then, things had taken a quantum leap, and the new features, the new machines they were forging were not like the ones of old that she was familiar with. They could think for themselves. They were centralized and virtualized, but most interestingly, they were located in a series of fortresses called the cloud. And the drifter thought about freelancing towards the north where tech was plentiful, but just before setting off, she had a chance encounter with a rogue program manager from the Citadel who was in distress. The PM had inherited a small band of laborers, tired of toiling on long-ranging projects, which rarely ever sent products outside the wall. They were hoping for a chance to make a difference. The PM knew if he couldn't get a product out of the gates, the Emperor would banish them. After hearing the PM's plight, the drifter decided to help, and the two formed an alliance, but on one condition. The PM would let the drifter guide them using DevSecOps, a new method she'd picked up while traveling through the Southern Passage. Now, this mystical methodology required the laborers to work more closely together on small batches and to collect data to help them improve. And whenever they could create a way to make a routine happen automatically, they would do so. And they would commit to getting their products to the townsfolk continuously, thereby helping them to survive the winter that was coming. Other guilds saw this and wanted in. Their leads asked that they could share resources and build together, continuously integrating their products. It wasn't long before the platform began to improve across the Citadel, and new products were leaving the gates at an unheard of rate. The tower keeps, who normally just watched beyond the walls and didn't care to leave their silos, started peering down into the main square where all the guilds had formed a pipeline from the engineering dungeons out to the market. The Drifter knew the tower keeps would be curious but hesitant to support these new configurations. So she scaled the tower walls and she made a deal to bring them information about the products that would help them to see farther out into the marketplace. If in kind, they would help the laborers with funds and strategy. Now, as you would expect, this meteoric rise did not go unnoticed in the High Tower. The Emperor called for the Drifter to share what she was up to, claiming avid curiosity and a desire to do what's right for the townsfolk. The Drifter was not naive. When speaking with a leader, one must combine decorum with savvy. After all, leaders have needs and goals of their own. The Drifter convinced the Emperor to gemba, or walk around the courtyard more and see the fruits of labor. She encouraged him to ask questions and provide insights. She showed him how the tower keeps were now involved in coming up with their own methods for supporting the flow of goods to reach the new territories. And most importantly, she showed the Emperor how experimentation was actually not a risk, but a requirement of improvement, and to view failure as an opportunity while promoting success as a shared achievement. Before long, everything started to flow. The code wasn't so heavy, rather more modular and secure. Engagement with the townsfolk revealed better ways to barter right off the pipeline. And alliances with forward-thinking citadels such as HashiLand brought new technologies that leveraged the benefits of the cloud machines to the north. The Drifter had done her job. The townspeople never forgot her influence. And with that, she moved on to the next adventure that awaited. Now, there's an epilogue to this story. Transformations happen in strange and unexpected ways. You can try to force them by concocting a magic potion, but that will just make you something you're not. Be careful not to fall victim to the Jekyll and Hyde nature of tampering with your teams and your culture. You may think you're improving their world only to find those pitchforks are marching towards your office in defiance of your sorcerer's ways. In fact, most transformations happen when you aren't looking. It can quite literally drift in when the right set of opportunities combine to ignite it. And like the weather, you can try to plan for it, but oftentimes your environment will dictate what will happen, and you'll have to be ready for what comes. It doesn't have to be purely organic. Yes, you can still plan to improve. But when it takes hold, it will impact every fiber of your culture. And it takes a different group of thinkers to fan those flames of change. You must be open to trying new things that are bold and probably a little uncomfortable. See, DevSecOps has a little bit of mad science in it, doesn't it? The brazen commitment to continuously searching for answers to problems that haunt your teams. But engineers are creatives as much as they are scientists. And when they see a problem, they're viscerally compelled to solve it, almost as if it's howling to them to invent a solution that's real. And it might just be something that will blow the townsfolk's minds. Beware of the engineer who harbors a great deal of passion. The reason we have the cloud is because of the storms they fought through to get us there. In conclusion, doing something like moving to the cloud for many organizations is a lofty idea, but like so many major paradigm shifts, it impacts the organization in more ways than you may expect. There's a culture shift associated with this kind of change. So here's the moral of the story. Technology is an accelerator, and to keep up, your teams must be agile. They must be allowed to organize for efficiency, and that can only happen when the organization trusts them with more access. Access to the customer, access to the business, access to the strategy. But it's hard to ask for these things, I get that. So don't be afraid to ask for help. You may not have the luxury of waiting for a drifter to wander through your doors. So be the drifter. Form positive alliances and share information. Generate this culture. And above all else, be on the side of good. Positivity in the face of change is what keeps it moving in the right direction, not skepticism and doubt. That is the path to the dark side. Like our drifter, work the change through engagement and buy-in. Bring a plan and be okay with it failing, and throw away your darlings if a better approach is needed. That culture of learning will allow the failure to be a useful lesson for improvement. And those lessons are the silver linings, and they're worth more than gold. The end. And now, Mike the Wanderer will tell us the story of automation.
All right, thanks, Chris, for sharing the tale of that epic journey. Well, my story starts where there was once this incredibly smart, experienced, and somewhat handsome DevSecOps or architect engineer. Like any good DevOps pioneer, he lived by the mantra shown here: automate all the things. You would often hear him squeal with delight during design sessions, or sadly, when just sitting alone, "We can automate that." Where this is wonderful and generally a good life philosophy, it can be taken too far. Now, I've never actually seen this, but I've heard from a friend that it can lead to messy situations where you can't tell where something has gone wrong. And it becomes next to impossible to drill down to the real source of the problem. Quite naturally, problems like this can lead from common automation patterns, like when this thing generates this code that is going to run and creates that file that is going to be piped into this thing, which is going to, well, you get the point. And we've all been there, right? All right, let me walk you through another example. So here we have where the bash script will set up for and run the Terraform from the command line. And then we add the Jenkins pipeline to run the bash script to run the Terraform. And now we write an API that calls the Jenkins to run the pipeline to run the bash script to run the Terraform. And finally, we need a portal that calls the API to call Jenkins to run the pipeline to run the bash script to run the Terraform. So when the portal has problems running the Terraform, where did it go wrong? How can you get down to that? Well, anyway, back to our mantra chanting engineer. They would often be found in odd sprawls in office chairs, staring at hundreds of windows across multiple monitors, with whiteboards and scraps of paper littered with illegible diagrams and lots of arrows going everywhere, and mumbling things like, "That passed that to there, but it looks wrong when it got to here." And people would walk by and look genuinely concerned and say, "Mike, take a break and come to lunch with us." I mean, Bob or Srini or Beth, whatever that engineer's name was. Okay, back to the point. You can automate a lot and should strive to, but don't do it to the point of making things so complicated that it is more error prone and much harder to debug and maintain. The KISS principle is not a bad mantra to include in your philosophy. Even in our example, there can be hope and balance in the force. Where the example here can just look as scary as the others, it does have some positive tenets, including reuse and the ability to address multiple use cases. It also provides a layered progression where when something goes wrong, you can back up the chain and run each piece in order to isolate the problem to its source. Okay, well, let's go on to the morals of the story. So automate, but don't over-engineer all the things. Think in progressive layers of clean separation, modular concepts. Have the bigger picture of the architecture defined up front as much as you can, but not to the point that you over-engineer that too. Consider the maintainability and the complexity as you're going through, especially as it gets into how you're going to debug these things, where the failure points are, those kind of things. And another mantra that we try to live by is to develop, test, and release the layers of functionality incrementally so that you can release often and release small pieces. All right, that's the end of my story, but it looks like there may be some rough weather in Bill the Stormbreaker's domain.
Hello, everybody. So my story begins in a time of great transition across enterprises around the world. Hosting facilities were under siege by the forces of the cloud, driving workloads and entire data centers into the cloud with the hope of lowering the cost of computing and increasing reliability and scalability of every workload. Data centers across the land were targeted for closure and removal, and application owners were told to move their applications to the cloud. Soon, a mass evacuation of systems to the cloud was on. The smaller and simpler workloads went easily to the cloud with no issues. In many cases, the data centers were closed. Well, data centers more like closets with servers in them, but you get my point. However, bigger, more complex data center workloads struggled a little bit to get to the cloud. There were a lot of questions behind how to do so. One of our clients consulted the IT oracles to try to get an idea of the best approach to get to the cloud. One of the first issues they brought up with the oracles was the substantial complexity in the workload. They brought up the fact that there was numerous components across numerous environments. It consisted of web servers, job servers, authentication servers, logging, reporting, mobile device management servers, all running on a combination of bare metal and virtualization. There was also a substantial amount of financial data involved in this system, and this financial data was the lifeblood of the organization. They could afford no downtime or loss of data during the migration. There was also a tremendous number of system integrations that were present, integrations with other external contract systems and financial tracking systems. And this also had to be live connections and also some replicated connections, but they could afford, again, no downtime with the virtualized data sources in particular. In time, they were going to be shutting the data center down within a year, so they had to move very quickly and yet cautiously. So the IT oracles regaled them with all kinds of options, mostly stemming from the Gartner 5 Rs. Obviously, the first of the 5 Rs is rehosting. It's potentially and theoretically the least expensive and fastest way to the cloud. What could be simpler? Just run P2V and move your VMs over and everything will be just fine. Unfortunately, it doesn't always work that way. The other possibility is to refactor, making only the number of changes necessary to get into the cloud with your environment that is very similar to what you're leaving. Then there's re-architecting and rebuilding, which is more advisable, which is where you take your workloads, you actually refactor them a bit to use cloud-native technologies so you get the benefit of moving to the cloud of all the managed services. And then the possibility of replacing the system. Well, this wasn't an option. The system was too critical, and there was no way to do that in 1 year. So needless to say, the winning selection from the client was rehosting. It was cheaper. That they stopped listing at that point. Cheaper and faster, and they went ahead with that pick. Now, the oracles did try to warn them a little bit about this and compared it a little bit to an iceberg, where they warned that with rehosting, you usually can only see the tip of the iceberg. You can't see all the factors that will impact you as you start the migration. So they went about and began doing the rehosting. And initially, everything was very exciting. Engineers came back rapidly and told them how quickly they were able to provision all the servers. They were able to get basic networking up in a prototype form. Enthusiasm was high. Everybody was celebrating that this was going to be an easy cakewalk. As the teams configured the networks, they started encountering issues. And then they also started realizing they had numerous problems that they had to face and resolve. The first was their own cloud readiness. While the team was very excited to get to the cloud, they really hadn't done their homework on how to best transfer on-prem workloads to the cloud. They didn't understand the limitations and differences between on-prem versus the cloud. So they ran into things like network security groups, mainly because this team never had to personally deal with firewall issues, et cetera. They actually had always relied on another organization to do that. So now they were confronted in this new DevOps model with having to do it as part of their own effort. Next, legacy documentation. Again, they were not ready. They didn't have an accurately defined system, which required them to go back and spend an exorbitant amount of time reverse engineering what they had to try to figure out how to get it to the cloud. So that was a problem. Next, their understanding of the licensing. They did not understand the difference between licensing in the cloud versus licensing on-prem. They assumed that the vendor would see everything largely as just a large on-prem environment, and this vendor did not. A particular vendor that they had actually came back and told them that they could not use per core licensing in the cloud because, in theory, AWS has unlimited core licensing. So instead, they got them to go to an enterprise license, which was far more expensive. There was no way of really cutting the cost down. Finally, the system integration issues. One thing that they had not considered was that their integration partners would absolutely refuse to deal with a cloud-enabled environment. This is changing more and more, and increasingly, most system integration partners will work with you. However, in this particular case, this was early on, and they did not want to have any connectivity to the cloud directly. So they had to go back and design a new network architecture that featured direct connections and VPNs. So things kept getting progressively worse over time. Our team kept fighting through issue after issue. The brave engineers had to write out a storm of endless risks, issues, challenges, and the delays kept piling up and the finger pointing began. And as many of you have probably gone through before, a death march ensued. The team responded to each crisis with steely-eyed resolve, but the endless issues just kept coming. Among the first of those issues was the performance. The system initially performed very poorly because the concept of taking a core that you had on-prem, on bare metal, and applying that to the cloud does not always work out the way you would hope. And so they had to continuously refactor their core counts and figure out how to allocate the right size VMs to make things work. The other is that the project went over budget. With all the issues that we've talked about to date, each one caused new engineering that was not anticipated to start with. Therefore, what ended up happening was they were finding themselves always behind the curve and having to throw more resources into resolving an increasing number of issues. Finally, they started seeing the bills coming in, and that's where things started getting really bad. The promise of the cheaper environment did not pan out, nor did the promise of the rapid move. So there was a lot of concern, and everyone became a little bit more anxious over time, which led to poor morale. While the team kept going and pushing, and they were dogged and relentless, they did start suffering worry and anxiety over this deployment. However, I'm happy to say our intrepid engineers weathered the storms and gained valuable lessons learned. They learned the myth of lift and shift the hard way. I wish I could tell you that lift and shift migrations are advisable, and maybe they are. And organizations with perfect documentation, perfect configuration best practices, and integration partners that are always agreeable, and maybe on workloads that are small and really simplistic and almost self-contained to limit the risks. However, I've never really seen those stars align on a project before. Migrations are opportunities to tell us just how well our system is architected and documented, and how mature our organization is and how ready we are to get to the cloud. But at the end of the day, replicating your environment config from config may require more planning time and patience than simply rebuilding. When starting a cloud migration, here are a few things to keep in mind. First, expect the unexpected. No matter what kind of migration you're doing, frankly, you will find some challenges of getting to the cloud, as cloud vendors have certain limitations to protect the security and the scalability of their environments, and that's to be expected. So do expect change. The second is embrace the change. Instead of trying to fight it and make things happen the way they used to, just come in with an open mind that the cloud changes everything and that you need to adopt the best that is available in the cloud rather than forcing the on-prem way of life. Know your workload first is another key item. This is essential. You need to make sure that you understand exactly what you're migrating, down to the lowest configuration items, that you are aware of what you have to map over to the cloud environment. This alone will save a lot of time if you do this up front. Plan for system integrations. Don't assume they will work the way they did the first time, because your vendors may have a say in this too, and they may object to what it is you're proposing. They may require direct connections, VPNs, or other paths to make sure the data is totally secure. Understand your licensing. Licensing is not always the same from an on-premise license versus a cloud-hosted license, and that goes across almost every vendor. Make sure you understand the differences. Finally, avoid lift and shift, and try to rebuild your architecture to a degree to incorporate as many good cloud-native technologies as you can. It will pay off in the long run, even though it may feel a little bit awkward and pricey when you're first starting out. So that kind of concludes the story here. And so this is interesting. As things are clearing up a little bit, we can see some shiny objects off in the distance. Elise the Fearless, can you tell us what's going on with those shiny objects?
I sure can, Bill. Thank you. And I hope that your skies in the future are much clearer. So I know everybody here is excited to hear about the lure of containers and other shiny things. So let me tell you a story about a container that weighed more than bare metal and a company that was having VM issues. Specifically, they were having a need for many VMs to build things, develop things, lots of VMs all of the time. Now, being a chronic overachiever, one engineer got frustrated. Too many requests were coming in and nothing was getting done. The VMs weren't being created on time, processes were slowing everything down, and everything was months behind. It was a complete mess. So our engineer spent nights and weekends coming up with a way to solve this. She wrote up a plan and brought it to anybody who would listen. Eventually it caught on. A supervisor of a supervisor was like, I agree. We're wasting money and time and not serving ourselves. So this engineer's plan got elevated. It called for good practices, automate, common infrastructure things like to help manage all of the cloud. As this plan rose higher in the organization, requirements grew, and unfortunately the idea was replaced. This is exactly what we need, one executive said, except this sounds like some foolery, homegrown by some engineers trying to do their own thing. Container engine. I saw a blog post online about it yesterday. We just give the developers these container things and all of our problems are solved. Now, of course, this made it back to the engineering team. Everyone was still excited. It was the acceptance of an idea and a chance to work with me. Our heroine was a little concerned, though. Her idea was based on a few small changes, many of them not a complete re-architecture. But it was a chance to make things better. And so she went along with it. In fact, she was made project lead because it was her idea. And so the project began, and everyone wanted to be a part of it. He bought 1,000 licenses of a far more expensive software than was recommended. Security purchased scanning tools and required specifically for containers. Compliance, well, they requested a meeting to discuss this fad once it had been. Program and project management said the engineering team will figure it out. And our engineer went to sleep. 6 months later, the container was ready. 4 months after that, the first container gets deployed. Now, this deployment went off without a hitch. However, the container was bigger and more resource intensive than the VM it replaced. It contained every agent on the VMs and some just for containers. The deployment review process took 3 of those 4 months to achieve approval, and the company bragged about it. 3 press releases were issued, and the company website now has a whole post about innovation. Our engineer now has a new list of priorities. Build relationships with everyone, security, compliance, senior leadership, developers, anybody who will listen so that we can avoid some of these unfortunate things. Start with technology that supports the ecosystem that already exists instead of creating a new one and all of the requirements that come with it. And spend a lot of time training the organization, because it's not as fun as playing the command line, but it's infinitely more valuable and can avoid a lot of the hiccups that will challenge us. I created these priorities to help my organizations face the lure of containers and other shiny things until we're ready. Thank you all for joining us. Back to you, Mike.
Great. Thanks, Elise. That's all of our storytellers for today. I hope you got a lot from those stories so far. We'll go see if the adventurers can answer any questions you might have about their quests. And if you do have questions or comments and haven't posted yet, please do that. We covered a lot today and in a different format. Let's see if we have some questions. All right. I am not seeing any questions in our box. Okay. All right. We have one here. Compelling stories. It looks like a lot, but how do we start? Who would like to take that? Maybe Elise?
Yeah, I can jump into that one. So over the last 10 years or so, I've kind of attacked a lot of different technology problems. Many of them started by tools that people want to implement. Unfortunately, a lot of the tools are brought on because people are having a problem. And so what I've found is the best way to start is by figuring out what the problem is and what we can do to solve the problem before we buy a tool. Now, there are a lot of tools that can be very helpful and work with the things that are, already there, but we have to transfer final commitment. And then we're ready to actually implement and use the tools that we buy on.
Okay, one more. This is from Tim. You mentioned DevSecOps earlier. Where and how does the sec part fit into this journey? Okay, I could jump in a little bit on that, and without going into the whole history of DevOps, but the sec part did get brought into that later in the picture. But as the DevOps practices evolved, and as our systems especially went to the cloud and went to even more potentially insecure environments, the need to intertwine security into everything we do became very obvious. And so just like some of the tenets of DevOps, which is to get some of these conversations, get some of the interactions between teams going early on, having the security concerns addressed as part of that became very important and continues to be. And, and obviously security is the first concern of many organizations that are in the cloud. And if you're dealing in even more secure systems, and government, federal type systems, it's just paramount that things are not penetratable, not able to be violated, and the community of the teams working together is what the DevSecOps part, but the sec refers to in that, as far as it's not other people doing security, it's everyone working together with the people that are the experts at the security to make sure that security is built in from the beginning.
Can I add a little bit onto that?
I can tag in.
Yeah.
Oh, go ahead.
Yeah, so what Mike said there is really, really key, and that is that the real value proposition is not to see security as another team. It's, your application must be secure every bit as much as it must be deployed, right? So it never made sense really that security would be a separate concern. It's got to be an integrated concern. And as you're engineering, you are frequently going to be answering a lot of your security-based questions. So it's good to have that security team there to actually capture that as it's happening, rather than as a post-mortem effort where you go back and update your documentation. So really, that's the first key, is getting the security team involved. But also the security team may be able to bring tools to validate and check the security of your application with every build. So that goes to your DevOps pipelines, where they could be involved in making sure your code starts secure, stays secure, and then you can kind of avoid that technical debt that it usually accrues due to security matters.
Yep. Very good. All right. Another question is, how closely should organizations look at the custom source code to identify open source risk, software quality, etc.? Would this be done to make sure an application is even ready for the cloud? Any strategies there?
I can take that one.
Yep.
So looking at, so our teams have done a lot of work with code that incorporates open source, and open source is probably one of the most valuable commodities out there right now, and it's definitely not something that we should do away with. In fact, it gets us closer and closer to low code type solutions and being able to leverage PaaS services like Lambda or functions, but open source code definitely does present a risk, and that's where we invest a lot of time in supply chain management. So making sure that we have a way of tracking everything as it goes through the process, and not doing it through as a paper exercise, but doing it as a part of our entire infrastructure provisioning process. Usually when we do this, it's no secret we do leverage a lot of the HashiCorp products because they work well with a lot of the infrastructure that's already there. But we tie in where we get our provisioning from secure repositories, where we essentially mirror the source code off of the internet, perform the scans, make sure that there's no vulnerabilities present, and then push it into our machine. One of the interesting things that we've really tried a lot lately has been trying to make sure that we are continuously matching or continue scratch, building it from kind of a good image, because open source is constantly changing, and if you maintain your own copy of it, it can become an operational risk, in that your kind of branch is starting to diverge away from the one that's actually generally getting security patches. And so, we have been really heavily using infrastructure and configuration as code, and our own custom code to make sure that we can go all the way back to the very beginning, pulling in those packages, and then taking it through the full supply chain every single time that we build, rather than just kind of building off of a golden image that lives for years. Hopefully that answered the question.
I'd actually like to tag a little on to that. So in addition to the supply chain perspective, we can also add on top of that kind of a continuous monitoring and auditing of any sort of open source apps or code we ingest. And by doing that, we're able to add another layer of security on top of supply chain management side.
Yep. Yeah, and I'll throw in and even a little bit from a HashiCorp products perspective, but we continue to very actively support open source and the communities and things, but it's still something that you need to build into your process, like we've been talking about, that you can't just accept anything that comes from the internet and just bring it into your build, and particularly into production environments. As you move up into more secure environments, in particular, where you may be air gapped or otherwise can't even pull readily, you should have vetting processes that go through and make sure that what you are going to release to production has been tested and vetted early on and scanned and validated. Okay. Here's another one. How does this journey help in delivering mission apps that require enterprise to edge delivery with high levels of security and maximum flexibility? Anyone want to start with that one?
Yeah, I can try to take a shot at it, and I'm going to turn my video off because it sounds like I've been a little choppy here. When we're delivering high security on things, one of the biggest security concerns that we often encounter when operating legacy systems or systems that have been around for many years is configuration and I guess, yeah, configuration would be the best way of saying it, configuration drift. So, we all deal with emergency requests and things that come in, and they've got to be fixed right now. The system's in operation, we're serving a mission capability, or something brand new came in and we have to build something up for it very fast. Scenarios, we put ourselves in a place where, that intellectual capital of knowing actually, what was built, how it was maintained, and, the other things that, every engineer knows while they're making compromises of, oh, I probably should fix this later. That all gets lost. And so, when we're delivering mission apps, that require high levels of security and maximum flexibility, we've found that the extra amount of time that it costs to put things into infrastructure and configuration as code and actually follow a sort of dedicated delivery process and supply chain, as we mentioned earlier, saves so much more money over time, even if it feels like the hours are bleeding away, on that first release or fix. So it's worth it for us.
Very good.
Actually,
right,
can I throw a little more onto that? Yeah, just as a quick note too is, it's a very interesting question, and I was focusing in on the part about having enterprise to edge delivery, and especially with the containerization story, if you can make sure that you're focusing always on developing very lightweight, svelte, container solutions, then one of the things I think you'll find is that getting to the edge becomes much easier. As a matter of fact, I've seen numerous demos across multiple platforms where basically enterprise applications are actually pushed to devices as small as Raspberry Pis, with Kubernetes running on it. So that really is keeping things very atomic, secure, and flexible as you build out is really the strategy to be able to get that edge delivery that you might hope for.
Yep, great. Okay, this next one is going into containers. And I would say the base is a little bit of that overall debate of containers versus machines. But it says, in the end, do you feel like creating fat containers with lots of stuff in them provided a benefit over dedicated instances? So, Elise, why don't you start with that one since you're the container queen?
Okay. So when containers were first coming out, they were super exciting because, a lot of these things like infrastructure as code and, provisioning out of templates was still very new. And so, typically, we were seeing containers basically as a solution for rapid provisioning and, tracking configuration of your infrastructure like you would your software, as well as being kind of a small, lightweight deployment with that overlay networking that was so fancy. And so, it brought all of these things and we were all excited, and the compromise of fat containers was okay because, we were still getting all of these other benefits. But now that we're in the world that we are now, 5 years from when we were going through the container journey, we're actually seeing that VMs themselves can be provisioned and can do all of the overlay magic and everything else that containers promised without having to sort of compromise the use case of containers. I will say that it was a great learning experience at the time, and it was a good prep for people getting into infrastructure as code and PaaS and SaaS services. But I would definitely advise, unless you're looking for that learning experience, to save containers until you're willing to start working, with scratch built containers.
Yep. Yeah, very good. And there was another question which overlaps with that, but there's always that decision point in terms of taking advantage of the tools and the facility that you're using. And it's the same as we're talking about, like Bill was talking about lift and shift and things like that, that if you're not using some of the technologies properly, you're not necessarily getting the benefit of the reasons out of them. And so when you do get to a point that you're just making containers that look like VMs, then you have to kind of challenge, is that where you need to be? And I think a lot of the container technologies have improved vastly over the past few years, with Kubernetes and things like that, and the ability to use them more wisely has become more transparent and easier.
I definitely would say as well that, like everything else that we're talking about, taking things in a piecemeal, measured approach is always the best way to go about anything. Jumping from a heavy VM environment to a container environment to any other type of service all at once, always runs into issues. The number one thing that I always kind of try to recommend is when you're thinking about something, try it, because you can think about it for months, but it's the second that you try it that you'll start to learn things. Right.
Very good. Okay. One here we'll go to is how did you address tech debt when trying to push aggressive timelines? And this person must have been experienced in the type of work we've been doing in the cloud with the aggressive timeline side.
If you want, I can take a first stab at that. Oh, go ahead.
Yeah,
Luis.
please do.
Okay. So generally, the one way I really recommend attacking technical deficit is not to let things build up to begin with. So case in point, I mean, there's numerous areas of technical debt that we talk about. There's the requirements we have to attack. There's the, from the functional side, there's the security, the operational, and automating your DevOps pipeline, I think, is really the most effective way to address this across the board. And in automating that DevOps pipeline, I have seen solutions where there was literally security scans run on every build. There was usability scans run on every build. Functional automated tests where possible were also automated. And the advantage of this is that every time the developer did a build, they saw a list of things they need to fix before they proceed on to the next thing. And in that, you can imagine that your technical debt, if it were to be graphed, would stay almost flatline because you would always only have 4 or 5 items per developer that they've got to track and mow down per build. So to me, that's the most effective. And, Lisa, can you think of others? Or
I can actually.
I can take another.
Go ahead, Luis.
Okay, I'll take a quick stab at it. Because I feel like I'm at a different place in my journey along tech debt management lately. So as one of those people who have many times, unfortunately, had to make the call about pushing tech debt backwards in order to make an important delivery timeline, one of the things that I have started to find the most valuable with managing tech debt is starting to build more measurements and more tracking of how the team is investing their time. Because the biggest cost of tech debt is in operations. Once you got something deployed and you're basically tiptoeing around the technical debt that you created, that's when you see the real cost. And making sure that you're tracking that cost and actually showing it makes a really compelling case to make sure that while you may not be able to stop supporting production, you can start to bring in help, or you can refocus certain efforts, or you can slow down marketing campaigns, and things that are basically limiting your ability to tackle some of the tech debt. Because sometimes we need to take a breath, but taking a breath when you've got customers to satisfy and margins to make, is hard to justify unless you can see the dollars and cents on the other side.
Yeah, actually, I weigh in here too as the hand-waving transformationalist.
Sure.
So from a tech debt perspective, there's also a business aspect to that as well. And Turn my camera on here. The business aspect is it's possible you might be in an organization that is okay with shipping with risk. You've got risk you're going to ship with that you're aware of. I couldn't fix that defect in time to ship. And then there's going to be the ones that we haven't got to yet, or we didn't know were lurking somewhere. It just hasn't been brought to our attention. So you may, in a lot of organizations, they'll sell a warranty. They'll set up a customer service branch. They'll say, this is okay. In fact, actually, we don't mind this. This is another revenue stream. You see this a lot in manufacturing, where they'll cover it that way. And they'll have, like Elise was saying, that they'll have some very interesting metrics that they'll be driving to try and calculate that, because to them, in the business level, it's an opportunity cost. Do I want to push a new feature out, or do I want the team focused on tech debt stuff? So one of the things you can do as part of the metrics that you're tracking is to try and identify a cost with that issue, with that debt. And generally speaking, we expect that the cost goes up the longer that tech debt exists, because it will impact more of the market, more of your customers, and possibly find its way into more of your systems design. So you sometimes need to bring it down to that level of conversation and make it very much a business decision. What do you want us to do? You can't make us type faster on the keyboards. You can't put two keyboards in front of me, but you can make us more efficient. So help us prioritize, since we can only do so much at any given point in time. Do you want that cost to grow on the tech debt, or do you feel that the opportunity cost of that growing will be overcome by the new features that they'll love? And then there's also the perception in the market. Are we of the grade and scale of a Ferrari, where every defect matters and we have a marketing campaign issue around that? Or are we a company that doesn't mind that so much and it's okay? We're kind of in that medium grade, and that's where we like to be. So there's some business side of this too. And they don't necessarily talk all the time. So somebody in your organization from the engineering side needs to make sure that they're communicating these kinds of thoughts to business. Otherwise, they don't think of it that way. I'm done.
Great. Yeah, thanks, Chris. I always appreciate from your perspective, and saying with a lot of involvement in transformation and agile practices. It's that tech debt problem is across the board, right, with all kinds of projects.
Sure.
Okay, we got a couple more. Let's do that as we go to wrap up. And one is that back to kind of the edge computing, but how does pursuing the cloud environments help solve edge computing challenges? And I'll start a little bit and then let other people jump in. But this, of course, is another challenge. It's coming up a lot more. There's sort of like DevOps, there's multiple definitions to what the edge is, what that means. But it's really a lot of it is, how do you even intermix secure environments, potentially exposing things to the cloud and reaching out into other areas across the world even. And the cloud does represent kind of this global presence that you can reach and can interact and can define networking in such that is very secure and yet flexible. And so it does bring you the opportunities to do that. The security and things, especially as you get into secure environments, is still utmost concern, but it can be done in ways that you can get the advantages of both sides of that. And a lot of government agencies, a lot of organizations are trying to get out of data centers or trying to get into other flexible environments. There's all kinds of reasoning behind that as far as doing the business you're good at and that kind of thing. So it's I think the time is here that a lot of the concerns about connecting things through the cloud are being alleviated, and there are a lot of ways to avoid security breaches and such things.
Yeah, I'll take a real quick addition to that.
Yep.
So, one of the big things about edge computing is, it typically has a higher cost associated with it. because you are, dealing with a more distributed, more sort of on-demand type of model, with all of these distributed devices. And moving towards the cloud or moving into an area of higher cost always, kind of forces the business to make a trade-off decision around, how much are we going to apply more rigor to our process and our system and the way that we manage things in order to make sure that we can sort of take advantage of the flexibility that is provided to us by cloud and edge and all of the other type of distributed computing solutions without incurring the costs that would be associated with basically replicating a data center type solution in the cloud. Because we know that replicating the data center with its static environments and building and leveraging the servers that you've already invested in costs more in the cloud. If you were to one-for-one replicate everything. So in order to make things cost effective, you have to really change the way your organization manages and ensures flexibility in everything it delivers. Which is where that journey comes into play.
Okay, let's say last one. It was mentioned that the sec came later in DevSecOps. Could it have been brought in earlier? And if so, how would you have done that? I'll let someone else jump in, and then I might add a few comments at the end.
Yeah, I'm happy to take this one. Unfortunately, security often is somewhat of an afterthought in DevSecOps, and well, it was DevOps before it was DevSecOps, right? So ways to bring it in earlier really boil down to experience, either individual experience or organizational experience. Organizational experience would be represented by, calling it DevSecOps, structuring your team so that there's a security SME or knowledge base that is flowing in when you're building the thing or when you're iterating. Other ways to do it is just more individual experience on the team, on the DevSecOps team, where everyone kind of has a finger in the pie and kind of knows what to expect along the security journey, knows what sort of allowable risks are there, and knows the security posture of the underlying system.
Yep, very good, very good. And the one other thing I would add is you kind of touched on, but it was always there. It somewhat became part of the title at some point, but as I mentioned earlier, the security part just became obvious, and a lot of people were doing it long before it became officially in the name. But it's going to continue, I think, maybe to get capitalized in the expression as we continue to go forward, because it's got to be there. Okay, well, I think we're going to wrap up for today, and it was definitely great to work with the ECS team and join us at HashiCorp putting on this creative webinar. I hope a lot of you gained from it, and those of you that will see this later on in the recording, thanks for your participation too. So keep an eye on the HashiCorp events page and the media feeds for more content coming out all the time. All right, bye for now.